Hello guys, I'm Gautam Possibility. I'm excited to talk about quantum computers and its applications and its limitations. So what is quantum computing? Quantum computing is a computing. So before I explain about quantum computing, you know how computing works. Computing works with bits of 1 and 0. So how quantum computing works is computation of qubits. Qubits is nothing but say if an electron spins, spins in a specific direction, it spins up. Okay, it's represented as qubit up. And if the same electron at a different point of time, or if a different electron rotates in a different direction, so it's qubit, qubit 1 and qubit B, qubit A, qubit B. So considering these two electrons spinning at different directions, and what essentially quantum computation does is computation of these qubits at superposition of these specific electrons at the same time. It actually involves superposition of it at the same time. At any specific time the electron moves at upper direction or lower direction. That's qubits. So using these qubits, quantum computation usually takes place, and quantum computing can be used for a lot of different applications. Like different applications, when I say it can be used for solving cryptography, it can be solved for a lot of very huge calculations involving math and involving involving different applications what you wanted to solve, like the features and the NP problems, N problems. But the limitations of quantum computers is that it not necessarily that it has to solve every problem, and a quantum computer has to be efficient in order to solve a specific problem when it actually minimizes the error. Say if the error is a specific error, if the algorithm is developed to solve a specific problem using quantum computing, the error which is caused has to be reinforced and it has to be rectified when the output is given. So that is one of the few things, limitations about quantum computers, because it cannot be used for all the different tasks as we know today. But it has a lot of applications, where it can solve huge problems with existing computations. Classical computations like supercomputers or normal computers can solve it, or it's very difficult for them to solve. So essentially, quantum computers, I would like to put in an analogy. So Einstein's equation E is equals to mc square. He said that the particle, what is the energy of the particle and everything. There is this thing like there is this uncertainty principle, Heisenberg uncertainty principle, which states that it is impossible to measure both the position and the momentum of a subatomic particle, because a subatomic particle it involves a very complex analysis to assess and interpret where the position and the momentum of any specific subatomic particle like electron or proton is at any specific time. But quantum computers could essentially could solve this problem with the computation with its the principle which stated by Feynman many years ago. The superposition principle is how it can do two different things at the same time. It's all about the quantum computing. How so? If, for example, if a particle exhibits electron exhibits both a particle nature and both a wave nature, and that is something. It's something very very analogous to what is a quantum computer essentially. So quantum computers could be used for a lot of different things. Like it can be used for forecasting weather, it can be used for forecasting disease outbreaks, who knows, it can be used for stock market analysis, finding different patterns and getting crucial insights. I think most of those things can be done with our existing AI, but the limitations what supercomputers cannot do, and most of the computers, it's finding it hard to solve. I think quantum computing has a huge role to play in that specific part, especially when you merge the quantum computing capabilities in the algorithms with the existing artificial intelligence algorithms to understand specific problems and to do specific assumptions and make it right. So that's about it. And if you like about quantum computing, if you wanted to know, check the description below and read more about quantum computing. Definitely, it's going to change the world. Thank you.